vertex form is y equals a times quantity x minus h squared plus k. Our quadratic function of parabola in vertex form will fit this design. Y equals a times quantity x minus h squared plus k. Based off the a, h, and k values, we can identify some interesting properties about this parabola. Your leading coefficient, your a value, just like intercept form, describes the concavity, how it opens up or down. A is greater than 0 or less than 0. X and y intercepts are going to be a little bit tougher in vertex form because it's not set up for you to find the x and y intercepts a little bit quicker, like it is back in intercept form. In general, to find the x-intercepts, any point on the x-axis has to have a y-coordinate of 0. So to find the x-intercepts in general just means plug in 0 for y. Vice versa, the y-intercept, any point on the y-axis, I'm just going up or down along the y-axis. I haven't moved left or right, so the x-coordinate for any point on the y-intercept has to always be 0. You can find the y-intercept by simply just plugging in 0 for x. Concavity, x and y intercepts. Here's the best thing about vertex form. The h and k values, these two coefficients form the vertex. The vertex is given by h comma k. The x-coordinate of the vertex is the h value. The y-coordinate of the vertex is the number on the end, this k value. All right, so up on Desmos, on the television screen, I've graphed the equation of a parabola in vertex form. I put the vertex form, y equals a times quantity x minus h plus squared plus k, here on the Desmos screen, and I've plotted the vertex 1, 1 on bottom. I've also included some sliders for a, h, and k here, so we can see what they're going to do to the graph as I let them vary. What's a value going to do again? This should be familiar too. Concavity. So let's let a vary and see what happens to the graph. It makes it open either concave up or concave down. When a is positive, the graph is opening up from the vertex on bottom. And conversely, when a is negative, it's opening down from the vertex on top. As a gets further from 0, it makes the graph really kind of steep, makes the parabola really scrunched in. For a values that are really close to 0, now it's much more spread apart, opening a lot wider. Right now, where's my vertex at? What's the actual point for the vertex? I know it's kind of hard to see up on the screen, so let's make sure we know where it's at. 1, 1 is the vertex, right? Let's change the h value and see how that's going to affect where the parabola is located at. I'm going to let my h value vary. Let's identify what's happening to this graph as h is varying from left to right. What's changing in the vertex as I let my h value vary? So it's just sliding it left and right, isn't it? It's not moving up or down. H is varying from left to right, and the graph is shifting from left to right. Pause it there. What's the vertex now? It's not 1, 1, it's what? 1.581. Because what's the h value that I paused it at? 1.58. So the vertex is right 1.58 and up 1. The h value controls where the vertex is at, left and right. It's the x-coordinate of the vertex. How about the k value? I'm going to let my k value vary now. How is the parabola changing here? Second Kale? Shifts it up or down. How far up or down to plot the vertex? Where's the y-coordinate of the vertex located at? I paused it. What's the new y-coordinate for our vertex of the parabola now? Negative 2.42, because didn't I pause the k-slider to be a value of negative 2.42? As you can see right here. Vertex form is set up for you to find the vertex rather quickly, just like intercept form is set up for you to find the intercepts without much effort. Okay. Then let's kind of see this in action here. Find the following and sketch a graph for y equals x plus 1 squared minus 4. Find the following and sketch a graph for this vertex form equation. Y equals quantity x plus 1 squared minus 4. First off, why is this in vertex form and not intercept form? What might be an indicator that this is in a different format now rather than intercept form? Vertex form. Yeah, go ahead.
It shows you squared.
Squared. It's a quantity squared. Rather than two quantities, when I have two different x-intercepts in the intercept form, now it's a single quantity squared. Different format designed to give us the vertex more easily rather than the intercepts. Concave up or concave down? Let's see if I put the a value back here, it's going to be a little bit more apparent. A value is actually 1 since there's no number there. So what do we think? Paige, what do you say? Concave up or concave down? Concave up. Positive a values open the graph up. Negative a values make it open down. X-intercepts. If I read the notes on the other board, to be a point on the x-axis means we have to plug in 0 for y. So let's take this y value and replace it with 0. My x-intercepts will now be however I solve this equation, whatever I get out when I solve this equation for x. Got to get x by itself to find my x-intercepts. It's going to take more work because that's not in intercept form. We're now in vertex form, so finding the intercepts is a little bit more challenging. Start moving some stuff to the other side of the equation. How do I get rid of subtracting 4? Let's start with that first. Add 4 to each side. Put a plus 4 on the right and the left. 0 plus 4 is 4 to bring down. And I'll have x plus 1 squared here on the right. Let's knock out the second power. I need to do something to both sides that would be the opposite of squaring something. What's the opposite of squaring a value?
Square root.
Take square root. For example, what's 3 squared?
9.
So wouldn't the square root of 9 be 3? What other number would be the square root of 9? What other number besides 3, when I multiply it times itself, would make 9?
3.
3 would. 3 times 3 is 9. What else?
1.
Negative 3. Negative 3 times negative 3 is also 9, since double negatives make a positive. So wouldn't the square root of 9 be either 3 or negative 3? Okay. So when I square root both sides here, square root, that knocks itself out. Those just cancel out like adding and subtracting did up above. So all I have left is x plus 1 on the right. Be very careful here. This is an easy place to make a mistake and forget a number. What's the square root of 4? 2 or negative 2, because taking the square root should tell me what number times itself makes that value. There's two numbers that I can multiply with each other to make 4. 2 times 2 and negative 2 times negative 2. Let's make sure I include both by putting plus or minus 2 down below. The square root of 4 is either 2 or negative 2. Last step to solve for x. Get rid of adding 1. Get rid of the plus 1 by subtracting 1 from either side. These are not like terms. I just can't put 2 minus 1 right here and call it plus or minus 1. I'm going to write them as two separate things. Plus or minus 2, minus 1 more. I can't combine these since they're not like terms. But I can simplify them a little bit by taking both the plus and the minus. I could have positive 2 minus 1. What's positive 2 minus 1? 2 minus 1. So there's an x-intercept. 1 comma 0. Now take the negative part of the plus or minus. What's negative 2 minus 1? Negative 3. I can have either 2 minus 1 or negative 2 minus 1. Negative 2 minus 1 means negative 3. And let's get a few more here. Y-intercept. If I plug in 0 for y to find the x-intercept, to find the y-intercept, just do the opposite. Plug in 0 for x. Change this x variable to be 0. So y equals quantity 0 plus 1 squared minus 4. All right, got to simplify by order of operations. So do the parentheses first. Charlie, what's 0 plus 1?
1.
What's 1 squared?
1.
Bring down 1 minus 4. 1 minus 4 should make what? Negative 3. When x is 0, we got negative 3 for our y-intercept. Much more difficult to find x and y-intercepts when I'm in vertex form. Here's where vertex form is really easy, when I want to find the vertex. Because it's pretty much just these numbers up above, with one minor switch. When I square a number, what's the smallest it could ever be?
When you square it.
When I square a number, what's the smallest I can ever get out? What's the smallest I can ever get by squaring a number? 0, right? Because when you take a number times itself, it can never be negative, right? Positive times a positive is greater than 0. A negative times a negative is positive, so greater than 0. I can never get out a number by squaring it that's less than 0. So let's make this as small as possible. Let's make this into 0, because it's got to be the vertex. It's got to be the minimum, as small as possible. What number plus 1 makes 0? So our vertex has to start with negative 1. People oftentimes see this as positive 1, so they put a 1 there. There's a plus 1, so let's just bring down 1 for our vertex. But does that make it as small as possible? What's 1 plus 1?
2.
2, and 2 squared makes 4. That's not the smallest I can make a number by squaring it. What gets me back to 0? A negative 1. Got to switch the sign. If x is negative 1, what does this first part of our equation become? Negative 1 plus 1 is 0. What's 0 squared? 0. So isn't this whole first part of the equation just basically nothing now? Using my x coordinate of negative 1. What's left over for the y coordinate? Extra minus 4. If you know what you're looking for, that's pretty easy. Vertex, negative 1, negative 4. There's your vertex. Much more simple to do that when I'm in vertex form as opposed to intercept form in practice on the wall. What's the line of symmetry? X equals. It's just got to go through the vertex point, Trevor. Whatever the x coordinate is here, just bring it down to repeat for your line of symmetry. Because the line of symmetry has to pass through the middle point of our vertex. Okay,
Because like the having to subtract 1, for the formula of the vertex, wouldn't you put like negative?
if you want to call this
Negative h?
like x minus negative 1,
Yeah.
that's the same thing too. So it's x minus h on the general form on the other board. So if you want to change this from positive to double negative, so you can see what you're subtracting and therefore make your vertex formula down here a little bit easier, that's fine. Maximum or minimum?
Minimum.
Minimum. What's the smallest number I can get out, Adley? The vertex. What's the smallest number I can ever get out? No, I could get out the minimum of -4 when I plug in -4. Let me pause here. Questions as we're looking at this example on the board? Now let's get your graph. Of course, I can just do a few points up on the board. X and Y intercepts, we can plot those. Here at 1, 0 and -3, 0. I could sketch the y-intercept by graphing 0, -3. And then I think the vertex would be good to plot too. -1, -4. I guess it's symmetrical, so this point here would be also on the left side if you wanted to use symmetry and find another point.